So here I'm going to go over a couple of facts and formulas that we need in order to be successful on our end of course test. All of these I'm about to go over are not on our reference sheet, so we just have to have them memorized. Starting with our quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. A couple things about the quadratic formula, that square root piece, make sure that is over all of b squared minus 4ac, that all of that is in the radical, and then all divided by 2a. Next up, standard form for a quadratic equation. Before you do anything with a quadratic, it's got to be in standard form, like ax squared plus bx plus c equals 0. It's got to be equal to 0 before you start pulling those a, b, and c values, say, for the quadratic formula. Sum of cubes. So if you are factoring and you have two perfect cubes that are being added together, it factors in the form of x plus y times x squared minus xy plus y squared, and you would use those values appropriately. This is where we use the acronym SOAP for those signs here. We have same sign, opposite sign, and then always positive at the end. So let's look at difference of cubes. Same scenario, you're factoring two perfect cubes, but they are subtracting. It's going to be x minus y times x squared plus xy, and the last one's always positive, plus y squared. Now, what if you had a difference of squares? What if they were perfect squares, like x squared minus y squared? That one's my favorite. It factors into x plus y times x minus y. Up next, we have the Pythagorean identity. That is sine squared theta plus cosine squared theta equals 1. On Delta Math, there is a place for a subscript. If you're having trouble finding that, let me know. But that is the Pythagorean identity. Now, during our lessons, I rewrote those formulas for you specifically if you were solving for sine or if you were specifically solving for cosine. So let's look at Pythagorean identity. If you're solving for sine, Pythagorean identity can be rewritten as plus or minus the square root of 1 minus cosine squared theta. And then if you're solving for cosine, we can solve by doing plus or minus the square root of 1 minus sine squared theta. Now, the Pythagorean theorem is different, right? Pythagorean theorem from 8th grade math, geometry, is a squared plus b squared equals c squared when you have a right triangle. We used that when we were solving questions using the unit circle, and we were given ordered pairs, and we were trying to find maybe a missing leg or a missing hypotenuse. Up next is discriminant. Discriminant is very closely related to the quadratic formula, so I probably should have listed it second on the list of formulas here. Discriminant is b squared minus 4ac. Look familiar? It's the little piece that's under the radical in the quadratic formula. So we don't give the discriminant a whole lot of credit because it doesn't help me find the actual solutions, but it can help me determine how many solutions we have. It can help me know if I have one solution, two solutions, imaginary solutions. So let's talk about that. I can use a discriminant to tell me if I have imaginary solutions, which is typically the questions that we see on EOC. If you want to know if you have imaginary solutions, use the discriminant and see if b squared minus 4ac is negative. If you plug in those values into b squared minus 4ac and you get any negative value, that indicates that you have imaginary solutions. Doesn't it make sense? In our quadratic formula, there's a radical. If the piece under the radical is negative, you know that's going to yield some imaginary solutions, yes? Average rate of change, we see this so much. That is your y2 minus y1 over x2 minus x1. They could ask from a graph, from a table, just from 2 points. So lots of questions they could ask about average rate of change. The square root of a negative 1 is your imaginary unit, I. If you have I times I, or you have an I squared, that's equal to negative 1. Two very important pieces right there for imaginaries. Moving on now to normal distribution. If you have your mean and you are one standard deviation away from that mean, either above or below, that is 68% of your data is going to fall within that range. If you are 2 standard deviations away on each side of your mean, that's 95% of your data. And if you're 3 standard deviations away, that's going to be 99.7% of your data. Let's review the coordinate plane. You'll need to know where your quadrants are, your first, second, third, and fourth quadrants. Let's also list our reference angles. So starting over on the right, we have 0 radians. Straight up is pi over 2 radians. All the way over is pi. Straight down 3 pi over 2. And then if you made a full circle would be 2 pi. They use these values sometimes to identify what quadrant that we're in. So if they said we're between pi over 2 and pi, that would tell you you're in your second quadrant. We also have our memorization tool, ASTC. All students take classes to help us memorize where our trig functions are positive. In the first quadrant, they are all positive, sine, cosine, and tangent. In the second quadrant, sine is positive, and so that means that cosine and tangent are negative. Third quadrant, tangent is positive, so sine and cosine would be negative. And in the fourth quadrant, cosine will be positive. The others, sine and tangent, will be negative. This can be one of the most helpful tools, just knowing ASTC and where your quadrants are. Usually with our multiple choice answers, if I know, hey, I'm in the fourth quadrant, so my sine answer should be negative, I might be able to get my answer choice simply from that. And lastly, our rational exponent rules. Your denominator in that exponent fraction becomes the index or the nth root of x to the m. And that m exponent can be inside the radical or it can be outside. As long as it's the exponent, it really doesn't matter. It doesn't impact the solution at all. And so going backwards, it's going to take my index and make that the denominator in the fraction of my exponent. So there's your facts and formulas that are not on our reference sheet that will be helpful tools for you during your end of course test.